Dear students, let us continue our discussion on this topic, that is our permutations and combinations. Let's get started with the first question in this series. Take a look at this question. Here it is given, in how many ways can a panel of 6 doctors be formed from 5 surgeons and 6 physicians if the panel has to include more number of surgeons than physicians? Okay. So if you get questions of this type, the first thing that you have to understand here is that, right, the supply first. Okay. So we have got 5 surgeons and 6 physicians, right? Okay. Now, the panel you have to form, the panel strength, it is equal to 6. And it is given in the question that there should be more surgeons than physicians. So, can I consider selecting 3 surgeons and 3 physicians? 3 surgeons and 3 physicians, if I consider 3 plus 3, it's equal to a 6-member doctor panel. But 3 cannot be considered, because if 3 is considered, the number of surgeons and the number of physicians in that 6-member panel, the number is equal. It's not possible, right? They have told you that there should be more number of surgeons than physicians. So 3 cannot be considered. So we can consider one case here, case number 1. Let us go for something like 4 surgeons and 2 physicians. This is case number 1. Okay. Case number 2, we can consider 5 surgeons and 1 physician. Okay. So you can see in these 2 cases, 3 cannot be considered. Then the number of surgeons and physicians will become equal. But we can consider 4 surgeons and 2 physicians. 4 plus 2, a panel of 6 doctors are happening. 5 plus 1, 6. You can again see a panel of 6 doctors are happening. Okay. Now, there are 2 cases here. Okay. So it could be either 4 surgeons and 2 physicians, 5 surgeons and 1 physician. 2 possibilities. Okay. So in how many ways case 1 can happen? It's all about selection here. From 5 surgeons, you have to select 4. The number of ways you can do it, it is 5C4. Combination, it's all about selection. So from 5, you have to select 4, means 5C4. 6 physicians are there, you have to select 2. The number of ways you can do it, it is 6C2. The process is complete only when you select these 4 surgeons and 2 physicians. So the number of ways that case 1, it can be handled, it is 5C4 into 6C2. Okay. We can calculate the value. In the same way, let us consider case number 2. 5 surgeons are there. All 5 surgeons are selected. The number of ways I can do it, 5 available, all 5 are selected. And 6 physicians are there, you select 1. So the number of ways you can do it, it is 6C1. So the number of ways 5 surgeons and 6 physicians can be considered. 5 surgeons and 1 physician can be considered. It will be 5C5 into 6C1. You can say 4 plus 2, it adds up to 6. 5 plus 1, it adds up to 6. So it may be case 1 or it may be case 2. Okay. So consider that logic or that I have written there. Now, the number of ways this case 1 can be considered, that is 5C4 into 6C2. When you do, you can see the number will come here as 75. 5C5 into 6C1 when you do. 5C5, it is 1. 6C1, it is 6. So The number of ways, case 2 can be considered, it is equal to 6. Total number of ways when you consider, it may be 75 ways or it may be that 6 ways. It's or. Or means it's addition. So you have to do 75 plus 6 and that is equal to 81. So as far as this question it is concerned, we can see that 81, option B reads 81. 81, it is my final answer. Okay. Let's consider the next question. In how many ways can a delegation of 4 professors and 3 students be constituted from 8 professors? So the supply, when you consider, it is 8 professors and 5 students, right? So from this 8 professors, 5 students, you have to form a delegation of 4 professors and 3 students. Okay. Now, in the question it is given one more condition. Balamurali, an art student, refuses to be in the delegation when Professor Siddharth, the science professor, is included in it. Which means these two people, they won't go together. They won't be there together. Okay, that's what basically this part of the input it tells you. So we can see that the supply, when you consider 8 professors are there, 5 students are there, you have to first consider selecting 4 professors and 3 students. Okay, the number of ways we can do it. That will be 8C4 into 5C3. In total, 8C4 into 5C3, this many number of ways we can constitute this delegation. Okay. Now, in this particular 8C4 into 5C3, there may be instances where this Balamurali and Professor Siddharth are together. Balamurali and Siddharth are not together. Both are there. So what I am going to do here is, from this 8C4 into 5C3, I am going to eliminate that possibility where Balamurali and Siddharth, those two people are there together. Okay, so the number of ways that can happen, you know what, when Balamurali and Siddharth are there in the delegation, if it comes, then what is the job that is remaining? From the remaining 7 professors, because already Siddharth is in. So remaining 7 professors are there. Balamurali, the art student, is already in. Remaining 4 students are there. Okay. What is the job from the remaining 7 professors, from the remaining 4 students? We need to select 3 more professors and we need to select 2 more students. This is the case where we are considering Balamurali and Professor Siddharth, they are there together. Got it? So the number of ways this can be done, you know, it will be 7C3 into 4C2. Okay. So this many instances are there wherein Balamurali and Professor Siddharth together, they are there in the delegation. But that is not possible. That's what it is said. So what you should do here, from this total number of possibilities, the way you can form this delegation, you exclude those many number of possibilities where Balamurali and Professor Siddharth are together there in the delegation. You subtract it. So 8C4 into 5C3, from that you subtract this 7C3 into 4C2. Got it? Now, we can easily calculate this 8C4 into 5C3. That will be constituting the value, it is equal to 700. From 700, you exclude the possibilities where Balamurali and Professor Siddharth are together there in the delegation, right? So that is 7C3 into 4C2. You know, 7C3 into 4C2, that value, it comes as 210. So you have to perform 700 minus 210, and the result, it is equal to 490. Okay, so for this question, the final answer, it will be coming as 490. So I shall quickly repeat what is happening here. We can see that there are altogether 8 professors and 5 students. You have to form a delegation of 4 professors and 3 students, like what I have presented here. The total number of ways this can be done, it is 8C4 into 5C3. But in this 8C4 into 5C3, there will be possibility that Balamurali and Professor Siddharth are together. So from this total, if you exclude that, you will be getting the possibility that Balamurali and Siddharth are not there together. Got it? So how it is done? Considering the case where Balamurali and Professor Siddharth are already there in the delegation, your job is now to take care of selecting 3 professors further from 7 remaining professors, 2 students further from 4 remaining number of students. The number of ways you can do it will be 7C3 into 4C2. So from this total, if you exclude the possibility where these 2 people are together there in the delegation, you will be getting what that is asked. 700 minus 210, the result will come here as 490. So for this question, the answer is 490. Okay. Let's go ahead with the next question. It's given Prahas attempts a question paper that has 3 sections with 6 questions in each section. So let us consider this is section number 1. This is section number 2. This is section number 3. Okay. The supply, when you consider, we can see that 6 questions are there in each section. Okay. So you read the first sentence here. Prahas attempts a question paper that has 3 sections with 6 questions in each section. So the question paper layout I have presented here. Now, if Prahas has to attempt any 8 questions, choosing at least 2 questions from each section, in how many ways can he attempt the paper? That is the question. So let us satisfy the condition. 2 questions from each section. 2 plus 2, 4, 4 plus 2, 6. He has taken care. Okay. Now, 2 more questions to be considered so that the total he is attempting, it is equal to these 8 questions. Okay. So I have satisfied the minimal condition 2, 2, 2. He has chosen at least 2 questions from each section. That is taken care. Now, 2 more questions are remaining. Those 2 more questions, how to go ahead with it? So the possibilities, if I'm going to list them, it can be like 3 questions from section 1, 3 from section 2, 2 from section 3. Or it can be 3 from section 1, 2 from section 2, 3 from section 3. Or it can be 2 from section 1, 3 from section 2, and 3 from section 3. Okay, so there are 3 ways. In the same way, it can also be like 4 questions from section 1, 2 from section 2, 2 from section 3. Or it could be 2 from section 1, 4 from section 2, and 2 from section 3. Or it could be like 2 from section 1, 2 from section 2, and the remaining 4 from section 3. Okay, so there are 6 different ways the attempt it can be made. Okay, so now if I'm going to consider the total number of ways in which Prahas can attempt questions from this question paper, if you consider, you can see that it could be, say, this case, if I consider, it will be something like 6C3 into 6C3 into 6C2. Because the supply is 6, you have to select 3, 6C3. The supply is 6, you have to select 3, it is 6C3. The supply is 6, you have to select 2, it is 6C2. But if you observe it, here also it is the same thing, only difference is 3, 2, 3 it is present here. Supply 6, you have to select 3, supply 6, you have to select 2, supply 6, you have to select 3. Please look here, supply 6, you have to select 3, supply 6, you have to select 3, supply 6, you have to select 2. So it's actually the same thing which is getting repeated altogether 3 times. Got it? So this first part, 332, if you are considering the total number of ways I can get this thing done, it will be 6C3 into 6C3 into 6C2 into 3. Okay, so that many ways it can be done. If you observe closely, something similar only it is happening in the second case what I have presented here, like 4, 2, 2. You can say again it is 4, 2, 2. You can again say it is 4, 2, 2. Okay, so the supply is 6. You are going in with selecting 2. Supply is 6, you are going with selecting 2. The supply is 6, you are going ahead with selecting 4. So the number of ways you can do it, it will be 6C2 into 6C2 into 6C4. Like that, like what you just saw, there are 3 different possibilities that I have presented. That 4 what you are selecting, it may be from section 1 or maybe from section 2 or it may be from section 3. Got it? So if you look at it, this is possibility 1, this is possibility 2 in total. So the total number of possible ways that Prahas can attempt all these questions in this fashion, it will be nothing but what you get as the answer in this first scenario plus what you are getting as answer in the second scenario. Like that, it will come. Okay. So now, if I am going to consider the results here, the final results here, I can see that here, in the first case, this will come here as 3000. Okay. That is 6C3 into 6C3 into 6C2. It will come here as 3000. Sorry, it will come here as altogether 6000. Okay, so this will be 6000 into 3 it will come. The second scenario what I have presented here, 6C2 into 6C2 into 6C4 into 3. Okay, when you are considering, that will be as good as 3375 into 3. Okay, so it may be this first scenario or it may be the second scenario. So you have to go ahead with addition. So you can now simplify this further. It will be 3 times 6000 plus 3375. And we can see this final result. It will be coming here as 28,125. Okay. So this way the calculation is done. Option C, you can say it reads 28,125. So for this particular question, the answer is 28,125. Okay. So please go ahead with the calculation of the 6C3. 6C3, it is 6 into 5 into 4 divided by 1 into 2 into 3. Okay. Into 6C3. Again, 6 into 5 into 4 divided by 1 into 2 into 3 into 6C2. It is 6 into 5 by 1 into 2. Okay. And this entire thing 3 times it is happening. So into 3. So you can see here this 3 into 2, 6 goes off. 3 into 2, 6, it goes off. So you can say it is 20 into 20. That is coming as 400 into 6 into 5 by 1 into 2, it is 15 into 3. Okay, so 15 fours are 60. You can see that it is 6000 into 3. That is how it is coming here. Okay, please observe. You can say this is how it is coming as 6000 into 3. Same way, you can go ahead with that 6C2 into 6C2 into 6C4. That is also happening 3 times. So like how we calculated, you can see the total will come here as 3375 into 3. It may be the first scenario or it may be the second scenario. So you have to go ahead with the addition part. So 28125, that is what you will be getting as your answer. Okay. So take a note of this question. Now let us go ahead with the next question. In how many ways 20 different books can be divided equally among 4 boys? So 20 books are there. Boy number 1, boy number 2, boy number 3, boy number 4. Okay. You are asked to divide these 20 books equally, 20 different books equally among these 4 boys. So you can thus see that the first boy will be getting 5 books, the second boy 5 books, the third boy 5 books, the fourth boy also 5 books. So it's all about dividing this 20 into 4 groups, each group consisting of 5 books. How many ways you can do it? It will be 20 factorial divided by 5 factorial into 5 factorial into 5 factorial into 5 factorial. Okay, so we can see that here, as far as this first question here, it is concerned, 20 factorial upon 5 factorial, the whole power 4 it will come. Looking at the options here, option D, it reads what I have identified. So for this question, choice number 4, choice D, that is going to be my answer. Okay. Now, let us consider the next question. A certain group of friends, they met on a New Year Eve party. Each person shook hands with everybody else in the group exactly once. And the number of handshakes, it turned out to be 66. So, I am going to consider what is given here up to this point. Let us consider that n people met. Okay, n people met in that party. So, the number of handshakes, okay, that will be equal to NC2. Okay, because when A shakes hands with B, I'm writing this in small letters. Okay, let us consider n people they met. The number of handshakes exchanged between these n people, it will be NC2. It is given that this NC2, the total number of handshakes exchanged, it is equal to 66. So n into n minus 1 by 2, that is given as 66 here. N into n minus 1, it is equal to 66 into 2. That is equal to 132. That's what we are getting here. But 132, if you are considering, it is 12 into 11. Correct? It is 12 into 11. So from this 12 into 11, I can consider that that is equal to 132. So from this, I can see that the number of people who attended that party, we can consider that is equal to 12. Okay, because when 12 people, they met and they did the handshake exactly once, then the total number of handshakes, it will be 12C2, which is 12 into 11 by 1 into 2. That is nothing but 6 into 11, 66. It tallies with what is given here. So the number of friends who they met in the party, that is nothing but the value. 1 second. That value, we can see that the number of friends, it is equal to 12. So I shall indicate it here. The number of friends that you are considering here, it is equal to 12. Okay. So that is the first part of the question. Now, further what is happening? On the occasion of Pongal, a harvest festival. If each person in this group sends a greeting card to every other person in the group, then how many cards are exchanged? Okay, so in the case of card exchange that is happening between two people, if there are two people, A and B, you can see that A is gifting a card to B, B is gifting a card to A. AB and BA, they have to be dealt with separately, which means it's about arrangement. The order is important. And here we can see that there are 12 friends and each person is sending a greeting card to every other person in the group. The question is how many cards are exchanged. So here the answer will be 12P2, which is 12 into 11 it will come. And that is equal to 132. Just consider if there are three people, A, B, C. They are exchanging cards between each other, exactly one card between each other. So 3P2, we can see that 3 into 2, 6 different cards will be getting exchanged. A gifting a card to B, B gifting a card back to A gifting a card to C, C gifting a card back to A, B gifting a card to C, C gifting a card back to B. So 6 it comes. See, so it's about permutation in this case. So here it's not 6 people, here there are 12 people. So the number of cards that is getting exchanged, it will be 12P2, which is equal to 12 into 11, 132. So the summary is, if there are n friends who met, the number of handshakes, write it down carefully, the number of handshakes, it will be NC2. And like here, it is asked the number of, say, cards that are getting exchanged. Okay, that will be NP2. So make a note of this. As far as N is concerned, handshake, it will be NC2. Number of cards exchanged, it will be NP2. So either way around, the first objective is to find out what is that value for that number of friends. I got it as 12. So you can see that here 12C2, that is equal to 66. It tallies with what is given in the question. Just now we found out 12P2, that is equal to 132. So the total number of cards that got exchanged, it is equal to 132, and that is my final answer. Okay, fine. So take notes, please. Let's go to the next question. Mr. Kapil, one of the members of the group that we have considered in the previous question, wants to invite home one or more of his friends from that group. Then in how many ways can the invitation be extended? Okay, so we can see that here, people you are considering, it will be like Kapil plus 11 others. Correct, no? Because total number of people we have identified, it is equal to 12, right? So Kapil, one of the members of the group, he wants to invite home one or more of his friends. Okay, so Kapil and his 11 friends. So Kapil plus 11, the number is becoming 12, right? So altogether, Kapil need to handle 11 friends. Got it? Kapil need to handle 11 friends. So if you are considering friend number 1, you can see that Kapil can consider handling that friend number 1 in 2 ways. What are they? That friend number 1, Kapil can invite or Kapil need not invite. So the number of ways that friend number 1 can be handled, it is 2. Similarly, the number of ways friend number 2 can be handled by Kapil, that is also equal to 2. The number of ways friend number 3 can be handled, that is also equal to 2. Okay, he may choose to invite that friend number 3 or not. So like that, it continues. Let us consider the 11th friend. The 11th friend can also be considered in two ways. May be invited, may not be invited. So when you are considering the total number of ways couple can handle all these 11 friends, you know how much it will be? That will be equal to 2 into 2 into 2 into 2 into etc. 11 times. So the total number of ways couple can handle all these people, you know, it will be equal to 2 power 11. Now, in this 2 power 11, there is one possibility that none of those 11 friends are invited. Listen carefully in the 2 power 11 because, you know, for every friend, there are two ways. Invited, not invited. Friend number 2, invited, not invited. Friend number 3, invited, not invited. So like that it continues up to 11th friend, right? Invited, not invited. So total number of ways all these 11 friends can be handled. It is 2 power 11. But it doesn't end there. In this 2 power 11, there is one possibility that none of the friends are invited. Okay, nobody is invited. Now read the question carefully. Mr. Couple, one of the members in the group, in the previous question, wants to invite home one or more of his friends from this group for dinner, which means nobody is invited. That situation is not there. At least one of the friends are getting invited, right? So from this 2 power 11, you exclude that single possibility where nobody is invited. That is not there. So my answer, you know, it will be 2 power 11 minus 1. 2 power 10 is 1024. So 2 power 11 will be 2048 minus 1. In this 2048, from that you are excluding that single possibility where nobody is invited. You are excluding that. So there you go. You will be getting the answer here as 2047. Okay. This answer will come here as 2047. We can say option D, it reads 2047. And that is my answer, final answer. Okay. This is a very interesting question. Please make a note of this. Let's consider the next question. Neha has 12 chocolates with her, 4 similar Kit Kats, 5 similar Perks, and 3 similar Milky Bars. She wants to distribute these chocolates among her friends. In how many ways can Neha give away one or more of the chocolates? Okay, so we can see that there are altogether 4 Kit Kats. These 4 Kit Kats, when you are considering, it can be handled in how many ways? The number of ways that 4 Kit Kats it can be handled. Neha can handle these 4 Kit Kats altogether in how many ways? In 5 ways. Okay. She may not give any Kit Kat. She may give 1 Kit Kat. She may give 2 Kit Kat. She may give 3 Kit Kat or all 4 Kit Kats. So the Kit Kats, you know, can be handled altogether in 5 ways. Please observe, Neha has got 12 chocolates. That's what it is said. 4 plus 5 plus 3. The total comes as 12. So these 4 Kit Kats, when you are considering, we can consider that she can deal with these 4 Kit Kats in 5 different ways. She may not give any Kit Kat at all. 1 Kit Kat or 2 Kit Kats or 3 Kit Kats or all 4 Kit Kats. So total number of ways, you know, 5 ways. Similarly, we can consider that there are 5 perks, right? These 5 perks can be handled altogether in 6 ways. Okay, she may not give any perk, that chocolate, to anyone, or 1 perk, or 2, or 3, or 4, or 5. So those can be handled in 6 different ways. Okay, in the same way, the 3 Milky Bars. Okay, these 3 Milky Bars can be handled in altogether 4 ways. Okay. No Milky Bar, 1 Milky Bar, 2 Milky Bar, 3 Milky Bar. So 4 different ways. Okay. Now, the total number of ways Neha can handle, it will be 5 into 6, 30 into 4. You can say this comes as 120. But you may think that 120 is the answer. But 120 is actually not the answer. The answer is 119. You know why? When you read the question carefully, it is given in how many ways can Neha give away one or more chocolates. Which means at least one chocolate she need to give, more is also fine. So in this 120, there is one possibility that Neha is not giving any chocolate to anyone. Okay, you can see that there is a case where no Kit Kat, no Perk, no Milky Bar. So there is one way in which none of the chocolates are getting distributed. That is actually not possible. Okay, like we saw in the previous question, right? We can see that here, none of the chocolates getting distributed. It is not possible because one or more chocolates are actually getting distributed. Okay, so from 120, you subtract this one, we can say my answer, it will come here as 119. Looking at the options, we can say option B, it reads 190. So for this particular question, my final answer, it will be coming as 190. Please be careful with this. The ways you can handle the Kit Kat. 0, 1, 2, 3, 4, 5. Okay, 0, 1, 2, 3, 4. I mean 0, 1, 2, 3, 4. We can see altogether in 5 ways the 4 Kit Kats can be handled. Okay, so make a note of that. Now, let us consider the next question here. From 3 green dice, 4 red dice, 2 yellow dice, the number of ways in which the dice can be selected so that at least one green die and at least one yellow die, it is selected. So let us take a look at the supply here. 3 green dice, 4 red dice, 2 yellow dice. Okay. Condition wise, there should be at least one green die, at least one yellow die. It should be there. So the number of ways you know, you can deal with one green die, it is equal to 2. Select that green die or don't select that green die. Like the three green dice are there. So the number of ways you can select all these 3 or deal with all these 3 green dice, you know, it is 2 power 3, 8. But here, one possibility where none of the green dice are selected, it is not going to be there because at least one green die it is there. Okay, so one green die, you can handle it in 2 ways. You select it or don't select it. Okay, green die number 2, select it or not select it, 2 ways. Green die number 3, select it or not select it. That's again 2. So total number of ways you can handle the situation will be 2 into 2 into 2. That is coming as 8. But in this 8, there is one possibility that none of the green dice are selected. But that is actually not going to be there because in the question it says there should be at least one green die that is selected, right? So 2 raised to 3, 8, 8 minus 1. The number of ways you can deal with these 3 green dice, it is equal to 7. 7 ways. Okay. In the same way, the 2 yellow dice when you are considering, 1 yellow die, 2 ways. So 2 yellow dice, 2 into 2, 4 ways. And in this 4, there is one way in which none of the yellow dice are getting selected. That is not possible. Excluded. So you can see that this will be 2 raised to 2 minus 1. That is 4 minus 1, 3 ways. Okay. Nothing is specifically mentioned about the red die. There are 4 red dice altogether. The total number of ways you can deal with those 4 red dice. You know, 1 red die, 2 ways. Red die number 2, 2 ways. So 2 into 2 into 2 into 2. I can say that is coming here as 2 power 4. Now, let's summarize or let's sum up all these things. The total number of ways you can deal with the red dice, it is equal to 2 power 4. Green dice, it is 7. Yellow dice, it is 3. So my final answer, it's all about dealing with the green die and the red die and the yellow die. So it will be 2 2s are 4, 4 2s are 8, 8 2s are 16. 16 into 7, 3s are 21. I can say this answer 16 into 21. This will come here as 336. Okay. So for this particular question, option A, it reads 336, and that is going to be my answer. Please be aware of this method, okay? The ways you are dealing with these green die, yellow die, red die and all. Okay, it's all about selection. That is what. Okay, fine. In the previous case, what you saw, you can see that it's not about selection. It is giving away one or more chocolates. The wording is different. That is why for 4 Kit Kats, she can distribute those 4 Kit Kats in 5 ways. Okay, so how many ways? You can see that here 0 Kit Kat or 1 Kit Kat or 2 Kit Kat or 3 Kit Kat or 4 Kit Kat. 5 ways she can handle with these 4 Kit Kats. It's all about giving it off. Okay, now here it is about selecting. That's all. One data is selection. The earlier case, selecting and then the person is distributing it off. So that's why that difference is coming. You may be wondering why I didn't do 2 power 4 minus 1. No, that is actually not needed over there. Okay, so make a note of that. Now, these two questions are somewhat similar, but one case it is about giving it off, other case it is about selection. Kindly make a note of the same. Okay. Now, let's go to the next one. P is an integer whose digits are zeros and ones. The sum of the digits of P, it is given to be 4. The range is given 10 power 5 less than P less than 10 power 7. How many values can this P it take? Okay, so if you observe, we can see that 10 power 5 is 10 power 1, 10 power 2, 10 power 3, 10 power 4, 10 power 5. Less than P, less than 10 power 1, 2, 3, 4, 5, 6, 7. So if you as such observe, this P, it can be a 6-digit number. Okay, because here it's all like 1 followed by 1, 2, 3, 4, 5, 5 zeros. The sum of the digits of P, it is equal to 4. So we can think of 6-digit numbers where you are dealing with further 3 ones and 2 zeros. Got it? Because 3 ones and 2 zeros, in how many ways you can actually distribute it. So P can be a 6-digit number, or this P, it can be a 7-digit number. Because here, when you observe, it's actually an 8-digit number. See this 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it can be this P what you are considering, it can be a 6-digit number. The P what you are considering, it can be a 7-digit number. So these two cases you should be aware of. Now, 6-digit number. Let's see what is happening. 1, 2, 3, 4, 5, 6. Definitely, it should start with 1. Got it? It should start with 1. It cannot be 0. Now, all the numbers that you are considering, they are associated with either zeros or ones. As far as here it is concerned, it's going to be either 0 or 1. And there, the sum of the digits of this P, what you are considering, the 6-digit number, the sum of the digits of this P, it is given that it is equal to 4. Okay, so now we can see that there are remaining 1, 2, 3, 4, 5. 5 positions are there. In these 5 positions, you have to fill 3 positions with 1 and the remaining two positions with 0. Okay, listen carefully. You have got altogether now 1, 2, 3, 4, 5. 5 places are there. In these 5 places, 3 places you have to fill it with 1. 2 places, you have to fill it with 0. So it's something like permutation with repetition of letters involved, right? So how many ways you can do it? It will be 5 factorial divided by 3 factorial into 2 factorial. Recall the example what we did, Mississippi assassination, mathematics. Okay, like that some words we have considered where letters are getting repeated, right? So here only zeros and ones are there. Totally there are 5 digits available. 3 ones and 2 zeros need to be arranged. How many ways you can do it? It is 5 factorial by, since 1 is getting repeated twice, 3 factorial, it is dedicated to that. 0 is getting repeated twice, 2 factorial, it comes over there. Okay, so this many ways you can handle case number 1. That is, if P, it is a 6-digit number. Okay, now what if this P, it is a 7-digit number? 1, 2, 3, 4, 5, 6, 7. So definitely it starts with 1. You can see that there are altogether 1, 2, 3, 4, 5, 6. 6 spaces are available. In these 6 spaces, you have to fill with 3 ones, and in the remaining, you have to fill it with 3 zeros. Got it? So you can see that 3 plus 3, 6, 6 plus 1, 7 digits are taken care. In how many ways this can be done? This can be done in 6 factorial divided by 3 factorial into 3 factorial. It will come like this. Okay. So when we are calculating it, you can see that this first guy, 5 factorial by 3 factorial into 2 factorial, when you do, you can see that this results in 10. In the same way, 6 factorial by 3 factorial into 3 factorial, when you do, you can see that results in 20. So it may be a 6-digit number or it may be a 7-digit number. So how many values can P take? The total number of values that P can take, it will be 10 plus 20. You can see that is coming as 30. And for this question, the answer, it is 30. Now, you may be wondering why I insisted that there will be only 3 more ones. One anyway there in the left hand most position. But why only 3 more ones? Because with that 3 more ones and this one, with altogether 4 ones, 1, 1, 1, 1, the sum of the digits of P is 4. 1, 1, 1, 1. The remaining 4 will be, the remaining 2 will be 0 in this case. The remaining 3 will be 0 in this case. So it will be something like 1, 1, 1, 1, 0, 0. Or 1, 0, 1, 0, 1, 1. Like that, possibilities could be there. Okay, so the number of ways that this can be done, this comes as 10 and this comes here as 20. All put together 10 plus 20, 30 it is the scenario. How many different values that this P, or how many values can this P take? That was the question. I can say 30 will be my final answer as far as this question it is concerned. Okay. I guess this is clear to all. Let us go ahead with the next question. Have a look at this question here. It's a very typical question. Okay, find the number of selections that can be made by taking 4 letters from the word inkling. Now, for the word in the previous question, inkling, find the number of arrangements by taking 4 letters. So please note, the same question, we are actually dealing with combination in the first part and permutation in the second part. Okay, so I shall just indicate it here, combination. Okay, and here I shall write permutation. That is about the arrangement I am saying. Okay, permutation. Please note, only after selecting those required letters with certain conditions, we can arrange them, right? So that's why I'm writing combination first and then dealing with permutation. So once I select them, then it is just a matter of arranging them, right? So I'm just focusing on selecting them in the first phase and then arranging them in the second phase. Okay. So the word that is given here, it is inkling, I-N-K-L-I-N-G. You can see that there are two I's here, I and I. Okay. Then we can consider that there are two N's, N and N. Then you have K, you have L, and you have G. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. Now, there are different cases that you have to consider. Okay. So, I shall present all these cases one after the other. Let us look at the first case. Case 1. Okay, you have to form 4-letter words, right? Case 1. All letters are distinct. Okay, all letters are distinct. So, in how many ways all 4 letters they are going to be distinct? I, N, K, L, G. Look at this. I, N, K, L, G. These are the 5 distinct letters. From this 5, you decide to select 4. Okay, from this 5, you decide to select 4. The number of ways you can do it, it will be 5C4. Okay, sometimes it may be INKL, or it may be INKG, or it may be IKLG. You can decide. So the number of ways that selection can happen, it is 5C4. So I have selected those 4 letters. All 4 letters are distinct. That can happen altogether in 5C4 ways. And the number of permutations possible, it will be 5C4. I have selected 4. Arrange those 4 selected in altogether 4 factorial ways. 5C4, it is equal to 5. 5C4 into 4 factorial when you do, it is basically 5 into 4 factorial. 4 factorial is 4 3s are 12, 12 2s are 24. 24 into 5 when you do, you can say the number of words that can be formed by arranging them, that is coming as 120. So this is case number 1, where all the 4 letters, they are distinct. Now let us focus on case number 2. Case number 2, what does it say? Case number 2 says 2 are alike and 2 are distinct. So I shall write 2 alike, 2 distinct. Okay. So how that is going to happen? 2 alike, 2 distinct. The 2 alike, it may be something like I, or it may be something like NN. Okay. So 2 alike, it can happen altogether in 2 ways. You can either go ahead with selecting the 2 I's or selecting the 2 N's. So the number of ways that selection can happen, you can be either loyal to the 2 I or you can be loyal to the 2N. So the number of ways you can handle that, it will be corresponding to 2. Okay, so that is the 2C1. Let me say I am loyal to that 2I there. Okay, now 2 distinct I have to select. How many ways I can do it? It is something like selecting N, K, L, G. 4 are available. Okay, I have to select 2 out of that. Okay, so please note, I am not dealing with NN, KLG. I am dealing with 1N, 1K, 1L, 1G. Suppose I am going ahead with the 2 I's, the 2 alike. Remaining I have is 1N, 1K, 1L, and 1G. Decide which 2 you have to select. The number of ways you can do it, it will be 4C2. So the total number of ways, it will be 2 into 4C2. What is 4C2? 4 into 3 by 1 into 2. 6 it will come. 6 into 2, you can see this results in 12. So the combination, the number of ways you can select the letters, that is coming as 12. I hope this is clear to you. Okay. So 2 alike. It may be either I or it may be NN. Those 2 are alike. Okay. So the ways you can handle them or decide them, it is equal to 2. Suppose I go ahead with II. Now, the two distinct what you are selecting, it may be like NK, NL, NG. Okay, it could be KL, KG, LG. So that's what I was trying to tell you. So 4 into 3 by 1 into 2. 6 it comes. 6 2s are 12, 12 altogether. You got it. So that is what the selection were two alike and two distinct it corresponds to. The number of permutation, it is again 12 into. Please observe here the ways it will come, it will be 4 factorial divided by 2 factorial. Why 2 factorial? Because the two are alike. Suppose I it is alike, it is permutation with repetition of letters as such. Sometimes it may be like I, N, K. So you can see that it is 4 factorial divided by 2 factorial. Okay. So that is what it is. Now, we can even consider one more case here. That is case number 3. What is that case number 3 all about? At case number 3, let me place it here. The case number 3, it will be like 2 are alike of one kind and 2 are alike of the other kind. So 2 alike of one kind, 2 alike of other kind. Basically, we are dealing with something like IINN. That's what we are considering. IINN. So the number of ways that can happen, that is equal to 1. IINN. Okay. The number of permutation, it will be nothing but 4 factorial upon 2 factorial into 2 factorial. Suppose I decide IINN, it will be like 4 factorial divided by 2 factorial into 2 factorial. Okay. So 3 cases are there. Case 1, all are distinct. Case 2, 2 are alike, 2 are distinct. Case number 3, 2 are alike of one kind, the other 2 are alike of another kind. Something like IINN. So we can see that now the total number of ways in which I can select, it's the combination I'm saying, the total number of ways I can select these letters, that will be nothing but 5 plus 12 plus 1. This answer, it is 18 here. Okay, the number of selection when you consider it is 5 plus 12, 17 plus 1, 18 it will come. What about permutation? You can see that this first guy, it is 120. The second guy, that is 12 into 4 factorial by 2 factorial. This value will come as 144. And you can see that this value, 4 factorial by 2 factorial into 2 factorial, it comes here as 6. So the total number of arrangements possible, it will be 120 plus 144 plus 6. 144 plus 6 is 150. 150 plus 120, that is equal to 270. So for the next question, the answer will be 270. Okay, so it's a very interesting question, this one. Slightly lengthy though, but see the varieties that we are discussing in this lecture. Okay, so make a note of this. Okay, let's go to the next question. Look at this. If the letters of this word notes are permuted in all possible ways, NOTES, and the words thus obtained are arranged alphabetically as in dictionary, then what is the rank of this word stored? So let me first arrange all these letters in the alphabetical order. So it starts with E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. Okay. So that set of words that starts with E, when you can consider that the number of words I can form that starts with E, it will be 1, 2, 3, 4, 4 factorial. 4 3s are 12, 12 2s are 24. 24 words can be formed that actually starts with E. Okay. So that is for the first one. Okay. Now, in the same way, that starts with n. Starts with n. Again, you can say 4 factorial. That is equal to 24. Okay. In the same way, those words that starts with O, that also will be corresponding to 24. Okay. Now, the number of words that starts with SE. I am fixing S. I am fixing E. SE. So 2 are fixed, 3 are remaining. So the number of ways I can arrange the remaining 3 letters, it will be 3 factorial. 3 factorial, you know, it is 3 into 2, 6. So that starts with SE, 6 possibilities are there. Okay. In the same way, the number of words that actually starts with SN, you know, that also will be 3 factorial, which is equal to 6. That starts with SO. You can see that that also will correspond to 3 factorial, that is equal to 6. So it's all about like starting with E, starting with N, starting with O, starting with SC, starting with SN, starting with SO. Then when it comes to ST, because you are asked to find the rank of this word stone, right? So it starts with STE when you consider. Step by step we are going. STE. STE when you consider, you are left with 2 more letters. The number of ways you can arrange them, you know, it is 2 factorial, that is equal to 2. Now remaining, it will be STN. The number of words that starts with STN, that also will be 2. And then comes STOEN and STONE. So this is 1 and this is 1. And finally, you can see when you are adding all these, that is going to get you the rank of this word stone. So let us add them. This is 24 plus 24 plus 24. You know, that is equal to 72. Okay. Now, there is 6, there is 6, there is 6. 18 it comes. 72 plus 18, you know, it comes as 90. Then you have 92, 93, 94 and 95. So after 95 words, as the 96th word, you can see that stone comes. So as far as this question it is concerned, they are asking you, what is the rank of this word stone? So after 95, as 96th word, you can see that this word stone is coming. I can say for this question, option B, 96 is going to be my final answer. Okay. So take a look at this, how we have arranged them for getting the rank here. Okay. So finding the rank of a given word based on the arrangements is another type of question that you should be familiar with. Okay. Now, there is another type of question, you know, it's all about finding the sum of all the 4-digit numbers formed by taking all the digits 2, 4, 6, 8. You can see that 2, 4, 6, 8, when you are considering all those digits, you know, they are distinct. So please note, one thing what I can observe here is all the digits are distinct. Okay. All digits, that is 2, 4, 6, 8. They are distinct. Okay. And second thing what you have to consider is you are considering all 4-digit numbers. Okay. And you are asked to find the sum of all 4-digit numbers formed by taking all the digits of 2, 4, 6, 8. Maybe it is 2, 4, 6, 8. You can permute it in different ways, right? So The total number of numbers that can be formed, it is 2, 4, 6, 8. 4 digits are there, 4 factorial. 4 threes are 12, 12 twos are 24. 24 different 4-digit numbers can be formed. The question is, what is the sum of all those 4-digit numbers that are formed with 2, 4, 6, 8? Okay. So sum of all those 24 numbers. So how to deal with this? Here, if the number of digits, it is equal to n, you have to start with something like n minus 1 factorial. Please note the general form is, suppose you are dealing with n-digit numbers, all the digits being distinct, you are dealing with n-digit numbers. First thing what you have to do is go ahead with n minus 1 factorial. Okay. Into 4-digit number, right? So you can put 1, 1, 1, 1. If it's an n-digit number, what you have to do is put 1, 1, 1, 1, etc. up to 1 n times. Okay, this is the general form. Okay, n times into sum of the digits. Sum of the digits involved. In this case, you can say you are dealing with forming 4-digit numbers. So n minus 1 factorial. 4-digit numbers, n is 4, 4 minus 1. The answer is something like 3 factorial into 1, 1, 1, 1 into sum of the digits involved. 6 plus 4, it is 10. 8 plus 2, it is 10. 10 plus 10, the total will come as 20. So what you observe here, sum of all those 4-digit numbers, the 24 4-digit numbers so formed, it will be coming as n minus 1 factorial. In this case, n is 4. So 4 minus 1, that is 3 factorial into 1, 1, 1, 1 into sum of the digits involved. So when you finish this calculation, you can see that the answer, it will come here as, I shall tell you, 3 factorial is 6 into 1, 1, 1, 1. So 6, 6, 6, 6 into 2 plus 4 plus 6 plus 8, that is 20. So the result will be 133320. Looking at the options, we can say option A, it reads 133320. So choice A is my answer for this question. So that pattern, what I have written there, make a note of it. When all the digits, they are distinct, we have n minus 1 factorial into, put as many number of ones corresponding to the number of digits. Here, 4 digits are considered, so I put 4, 1, 1, 1, 1 into sum of the digits involved. I'm giving a small task for you. At your convenience, you try to find out what will be the case if the digits are not distinct. Here, all the digits are distinct. Learn by yourself what will be the case if the digits are not distinct. How are you going to find the sum of all those numbers formed by taking the digits? Okay. So if the repetition of digits are happening, how you are going to deal with it? That's a small task which I ask you guys to consider. Okay. Now, let us consider another question. There are 12 points on a plane. So they are lying scattered. 4 of them are on straight line and no other 3 points are on straight line. The question is, find the difference between the number of triangles and the number of straight lines that can be formed. Okay. So we can see that if there are altogether n points, okay, n points in total we have, out of which, please note, m points are collinear. Okay, altogether n points, out of which we can see that m points, they are collinear. Okay, so case number 1, number of triangles that can be formed, it will be NC3 minus MC3. Because to form a triangle, we need 3 points, right? So altogether, if there are n points in total, out of which m points are collinear if it comes, the number of triangles that can be formed, it will be always NC3 minus MC3. Okay, because to form a triangle, we need 3 points. NC3 minus MC3 because m points are collinear. Okay, so that is what you have to do. Second one, the number of straight lines that can be formed. See, in order to form a straight line, we need the help of 2 points. So if all the endpoints are lines scattered, none of them are collinear, the number of lines I can form will be NC2, right? But here, since m are collinear, you exclude that MC2. But please note, connecting that first m are collinear, I said, right? So the first one and the last one, connecting them, I can actually draw one line. So please note the number of straight lines formed, it will be NC2 minus MC2 plus 1. Okay, so don't forget that plus 1 also, because just observe 1, 2, 3, 4, 4 points are collinear. So like this, if I am joining, okay, AB, CD, you can see that AB, BC, AC, AD, BC, CD, they all are single straight line. And they all are falling or overlapping also. So I remove all those and then put just that AD, the single line. So that is the significance of this plus 1 over here. Okay. Now, even if you are not diving deep into the theory part, just you can form or by heart this shortcut formula that I have presented. There are n points in total. Out of those n points, assume or consider that m points are collinear. So number of triangles will always be NC3 minus MC3. Number of straight lines formed will be NC2 minus MC2 plus 1. This is in general. Okay. Now, coming back to our question, we can see that here altogether the total number of points, it is equal to 12. It is given that 4 of them, they are in a straight line. They are collinear. 4 of them are collinear. So we can consider the number of triangles. It will be 12C3 minus 4C3. Okay. When I simplify this 12C3 minus 4C3 when I do, this will come here as 220 minus 4, that is equal to 216. Okay, this is one answer. In the same way, the number of straight lines that can be formed, number of lines, the straight lines that can be formed, it will be 12C2 minus 4C2 plus 1. And that will be nothing but 12C2. It is 12 into 11 by 1 into 2. It will be coming as 66 minus 4C2. 4 into 3 by 1 into 2. That is equal to 6 plus 1. I can say this results in 61. Okay, that many number of lines you can form. But the question that is asked here is, what is the difference between the number of triangles and the number of straight lines that can be formed? So you are asked to find what is the difference between them. How to find that? That will be nothing but 216 minus 61. And that results in the number here as 155. Okay, so the difference 216 minus 61, I can say that will come as 155. So for this particular question, my final answer, it will be coming here as 155. And in this lecture, we will go for one more question. For a convex octagon, what is the maximum number of points of intersection of the diagonals inside the octagon? So for answering this question, you should be knowing a small shortcut formula. For a polygon, a convex polygon, it's important. For a convex polygon, Write it down. Okay. With n, I should say, sides. Okay. For a convex polygon with n sides, the number of points of intersection the number of points of intersection of diagonals. Okay. You know what it will be? There's a shortcut for it will be NC4. Okay. For example, let us consider a square or a rectangle. You can see that the number of sides it is equal to 4. The number of points of intersection of the diagonal, you know, it is 4C4. Okay. So we can say 4C4, it is equal to 1. This is one diagonal. This is another diagonal. You can see that there is one point of intersection. Same is applicable with other polygons with more than 4 sides. Okay. So this is what you have to note here. The number of points of intersection of diagonals, you know, it will be NC4. In general, you can use this result. Now we are dealing with a convex octagon. So given we are dealing with a convex octagon. Okay. So we can see the maximum number of points of intersection of the diagonals inside that octagon. Number of points of intersection of diagonals inside the polygon. Okay, that is equally important. Okay, so that will be nothing but in this case octagon. Octagon means n it is equal to 8. Okay, so my answer will be 8C4 in this case. Okay, make a note of this. My answer will be 8C4. 8C4, when you calculate, you know, it will come here as 70. So option C, it reads 70. Okay, just if you know NC4, that's enough. So that is the shortcut, you know, which we are revising now. So a convex polygon with n sides, you are considering the number of points of intersection of the diagonals inside that polygon. It is given by that formula NC4. So given it's a convex polygon, so n is equal to 8. So the number of points of intersection of diagonal inside that octagon, you know, it is 8C4. It is as good as 8 into 7 into 6 into 5. Let's quickly do it. 8 into 7 into 6 into 5 by 1 into 2 into 3 into 4. Okay. So this 2 and this 3, it goes off. This 4 here will go in this 8 twice. 7 5s are 35 into 2. The value will come as 70. And that is my final answer, as you can see. Okay. So with this question, we are concluding our second lecture that is based on our permutations and combinations. One more lecture we will have in which we will be covering some more advanced level questions that involves derangements, some questions that involves, I should say, grids, some questions that involves finding the number of ways in which some distributions can be made. Okay, wherein the number involved are positive, the number involved are non-negative. Those concepts we shall discuss, and that will be part of our third lecture in the series based on quick revision based on our permutations and combinations. So stay tuned.